Okay, so just a couple problems I'll walk through here from working on simplifying exponential expressions with rational exponents. So suppose you got something like 64 to the 1/3. There are lots of ways to attack this. The one thing you want to remember is that 1 over 3 as an exponent indicates you're looking for the third root of 64. And at this point you simply can go ahead and say, I'm going to answer the question. Something cubed equals 64. The answer is 4. That would be one way to go about it, because you're looking this as the cube root of 64, and you're done. Another way would be to recognize that 64 can be written certainly as a power of a base, either 2 or 4. So you're looking at, for example, if you were to write it as a base of 4, you got 4 cubed is 64. 4 cubed to the 1/3 would be 4 to the 3/3, which is 4 to the first, which is 4. So there's another way to look at it. If I looked at that 64 as a base of 2, 2 to the 6th is 64 raised to the 1/3. Use my laws of exponents. That would be 2 to the 6/3. That would be 2 squared. Let's try. And you get 4. So again, some of these problems, there's not just one way to look at them. You can get there in a number of ways. Okay, so let's suppose I've got some rational number here, a quarter, raised to a negative exponent. The way I do this is reciprocate immediately. The reciprocal of 1/4 is 4. That exponent becomes positive, and I get 64, and I'm done. If we actually slow that process down, just to show you why it works, if I look at that 1/4 to the negative 3, by definition, that's going to be 1 over 1/4 to the positive 3. I then can go ahead and simplify internally, and 1 over 1/4 is 4, and 4 cubed is 64. I could also start the problem off by simply saying, hey, a fraction or a rational number raised to an exponent is numerator to denominator. Distribute that exponent through. That's 1 over 4 cubed, which equals 1 over 1/64, which equals 64. Get to the same place. And there are other ways to look at just this simple little problem, a quarter raised to the negative 3. But there's 3 ways. So I never like to work with radicals, and maybe you enjoy working with radicals. I don't. I'm asked to simplify this expression. And what I'm going to do is, first of all, convert everything to exponents. So then I'm looking at a 7 to the 1/5. That then is raised to the 1/4, which is then raised to the 1/3. I then go ahead and can use my law of exponentiation here. That 7 to the 1 over 5 times 4 is 20 times 3 is 60. And if I want to rewrite that as a radical expression, that's going to be the 60th root of 7. Okay, a couple things here. First of all, 625 is a number you certainly should recognize as a power of 5. 5 squared is 25. 5 cubed is 125, and therefore 5 to the 4th would be 125 times 5 is 625. So I might say, hey, this is 5 raised to the 4th to the x equals 1. 5 to the 4x equals 1. I get kind of the same place in this because, and again, I can solve it as such. What do I raise 5 to in order to get an output of 1? And that exponent here would have to be a 0. Because anything to the 0 equals 1, and therefore x equals 0. I could have recognized that initially right in the problem. I'm raising 625 to some power, and I got to get an output of 1. The only power that is going to give me an output of 1 for an exponential expression is 0. So I simply could have answered x equals 0 right back at the beginning. Now, if I want to take 36 and raise it to power to get 0, my quick answer is there is no solution here, because I can't raise 36 to any power and get 0. And if you think about that, if I take 36 and raise it to a power, 36 squared is going to be some huge number. 36 to the first is 36. 36 to the 0 is going to be 1. And then if I keep going down with negative exponents, 36 to the negative 1 is 1/36. So that's going to be down here pretty close to the x-axis. 36 to the negative 2, well, that's 1/36 squared, getting closer and closer to 0. But will I ever get there? 36 to the negative n, assuming n is positive, is going to be 1/36 to the n. A fraction with a numerator of 1 is never going to be equal to 0, and therefore 36 raised to the x power can never equal 0. Answer is empty set. Okay, so again, if I've got a negative exponent, the first thing I'm going to do is reciprocate internally, and then that becomes a positive. And then if I think about this, I've got two options. I can either take the 625 and 256 and cube them first, and then take the fourth root. Do I want to be cubing 625? Not a good choice. So what I want to do is make sure that I'm going to view this as 625 fourth root, 256 fourth root, take those and then cube them. Well, the fourth root of 625 is 5. The fourth root of 256 is 4. 4 squared is 16. 4 cubed is 64. 4 times 64 is 256. So then I want to take 5/4 and cube it, and I'm ending up with 125 over 64. Voila. So two ways to look at this one. I think if you recognize that you've got a common base here, root 2x, the first thing I would do is take that root 2x, which is a common base in numerator denominator, and just use my laws of exponentiation, which would be 5 minus 9. So I get root 2x to the negative 4. Let's reciprocate. That's 1 over root 2x to the fourth. Well, let's see if I think about that squaring. Root 2x squared times root 2x squared, that would be 2x times 2x, and I'd get here, 2 times 2 is 4, 1 over 4x squared. Another way to look at it would be to say, well, take that root 2x to the fifth and actually do it. Take the root 2x to the ninth and actually do it. And let's see what we get here. Root 2x, that would be root 2x squared, root 2x squared times root 2x over root 2x squared, root 2x squared, root 2x squared, root 2x squared, and actually one more, root 2x squared. 2, 4, 6, no, one too many. Hold on. Root 2x, 2, 2, 2, it's 2, 4, 6, 8, and one more, root 2x. And then what happens? Cancel, cancel, cancel. That leaves me 1 over root 2x squared, root 2x squared, which is what we got in the last expression, and that's going to be 1 over 2x times 2x, 1 over 4x squared. Get to the same place. A lot more work. If I recognize that I've got a common base here in the beginning, becomes a pretty simple problem. Actually going and distributing through a lot more work. Okay, so here's another problem from 5.2. 8x to the negative 3 equals 64. First thing I'm going to do, I don't like working with negative exponents, so I'm going to look at that as 1 over 8x cubed. And I'm going to look at that 64 and see that that's a 4 cubed. I now have something cubed equals something cubed. Well, cube roots then would have to be equal. Therefore, 1 over 8x would have to equal 4. And I solve 32x equals 1 if you want to go ahead and cross multiply. And then x is 1/32. Different way to do it? Sure. So, different way, I'm going to go ahead and distribute that exponent of negative 3 through my parentheses, still noting that 64 is 4 cubed. Rewrite the 8 to the negative 3 is 1 over 8 cubed. Go ahead, solve for x to the negative 3. Go ahead then and say reciprocate, which is going to give me x cubed is 1 over 8 to the third, 4 to the third, and then take the cube root of each side. Cube root of x cubed is x, cube root of 8 cubed and 4 cubed is 8 times 4, and you still get 1 over 32nd, 1/32. Okay, so this is number 48. I'm looking inside that cube root, and I'm seeing I've got a 2 cubed and a 2 to the 4th for the 8 and the 16. So I'm actually going to go ahead and work just inside the cube root for a minute here. And so I've got 2 cubed x plus 1 over 2 to the 4x cube root 32. I then go ahead and then use my powers of exponents here and get 2 to the 3x plus 3. Why, that's horrible. Let's try that again. 2 to the 3x plus 3 minus 4x equals 32. And then I'm looking at the cube root of, let's see, that would be 3x minus 4x is negative x, 2 to the 3 minus x equals 32. Now go ahead and cube both sides, and I'm looking at that 32, which is a 2 to the 5th, so then I'm looking at a 2 to the 3 minus x, and if I cube both sides, that's 2 to the 5th cubed. So 2 to the 3 minus x equals 2 to the 15th, and therefore then I'm looking at a base on each side raised to a power, therefore the 3 minus x is going to have to equal the 15, and therefore x equals, let's see, move the x over there, the 15 over there, negative 12 is what I get. I think the key in looking at a problem, there are other ways to go after this one as well, but I think one thing that I look at, you see an 8, a 16, and a 32 all have, can be written as a power of 2, and the big idea is get to, if I've got a power of 2 raised to an exponent equals a power, if I've got a power of 2 and I've got a power of 2, then if those expressions are equal, then my exponents would have to be equal. And so right in the beginning of the problem, I can see that perhaps I can rewrite this whole side as a power of 2 and rewrite this side as a power of 2, which is real easy. It's 2 to the 5th.